Hello all, welcome back to my YouTube channel Mukesh Tech. And today I'm going to show the practical implementation for the receiver operator characteristic curve and area under the curve. So in my previous video lecture I have covered the theoretical session, what is the ROC AUC, what all are the benefits and what all are the prerequisite for that one. So in this video lecture I'm just going to take the practical implementation for this ROC AUC curve, right? So first let me import the required libraries. So guys, here I'm importing make underscore classification. So if you are not sure what does that mean, make underscore classification, so this library generates a random classes, n number of classes. So because here I don't have any data set, so I'm just using make underscore classification for generating the classes, because this is the ROC AUC curve for the binary classification, and binary classification means only for two classes. I'm using train test split for splitting the data, logistic regression as well as k nearest classifier, because logistic regression is also part of the classification problem and KNN is also. And here I'm going to compare both the classification algorithms, which one is performing well on the data. I'm taking a ROC underscore curve from the scalar and ROC AUC score just to check the score, which one is performing well. So guys, here I'm just calling make underscore classification. Let me show you the parameters that is going to accept. First let me run this first cell so I can get the access for the next cell. So here let me show you what parameters are going to accept by the make underscore classification, and it's a very important, guys. For any methods you are using from the predefined libraries, you need to check the parameters accepted by that function. So here make underscore classification says like it's accepting n sample, n feature and some n underscore classes, and many more parameters are there, right? Random state. So I'm just taking the required parameters. Here I'm taking n sample equals to 1000, classes equals to 2, feature equals to 20, and random state equals to some digit that is 12, right? After that I'm splitting the data set between the train test. So here I'm calling train test split, just passing the argument as xy, and I'm giving a splitting ratio test size that is 0.3 and a random state equals to 12. So here if you will see, already I have imported the logistic regression classification problem algorithms and the k nearest classifier. So just to use these algorithms we need to these models we need to create the instance, or I can say the object for them. So here I just created logistic underscore model for the logistic regression and kn underscore model for the k nearest classifier. So similar to previous, if you will look at the parameters in the k nearest classifier, so it says like n underscore neighbor is the parameter and by default value is the 5, but here I'm selecting is 4. Now let me run this cell. After the creating the instances for the model, we need to fit the model on our training set, right? For getting the prediction, first of all we need to fit the model on the given training set. So already I have splitted the data between the training and test set. So here I'm passing the x train, y train in the logistic model similar to k nearest model, right? So here we got the output as n underscore neighbor equals to 4, because by default was 5 but I gave as 4. So guys, this is very important, predicting the probabilities. So in theoretical session I have explained, if we are going to draw a diagram between FPR and TPR, that is false positive rate and true positive rate for ROC AUC curve. So the diagram and the data points we are selecting, that is based on the probabilities. So just to calculate the probabilities, what I'm doing on the instance for the logistic model, I'm just calling the method as predict underscore probability and I'm passing the test set, that is x underscore test. Similar to k nearest model, I'm just calling the predict underscore probability function. I'm just giving x underscore test. Now for create ROC curve for the model, right? So as just now I have explained, like we need to calculate the true positive rate and false positive rate. So I'm just calculating the false positive rate, true positive rate and the threshold. So guys, threshold level is the very important, because better the threshold, better the ability to predict, or we can say classify the classes, right? So here I'm just calling ROC underscore curve. So in the library, if you have seen ROC underscore curve, I have imported. So ROC underscore curve, and I'm giving the parameter y underscore test, and I'm just calling probability underscore logistic underscore model. So this is the instance that we got the probabilities. So if you are not sure, let me show you what all are the values contains this instance. So here you can see a list of probabilities is having inside this one up to 1000, because I'm taking the classes as sample as 1000, right? And here guys, you can see there are the first, before column, the first one, it says all the rows, and after comma it says the first column. So we need to take all the rows from the first column, right? And we are calling a parameter post underscore label equals to position, setting the label position at 1. Similar work I'm doing for the k nearest model, calculating the probability and giving it to the ROC curve, and with all the required parameter y test, probability for kn model, similar parameter to logistic regression. Now we need to have this ROC curve for TPR and FPR. So I'm taking the length, the complete length for the testing data set, right? Now this is the very important, check the score for AUC. So what all are the score, because already I have used this logistic regression and k nearest neighbor, so I need to check the score, which one is performing well. So in under the ROC underscore AUC underscore score, if you will see what all are the parameters, it says y underscore true and y underscore score, and these are the parameters that is going to accepted by the ROC AUC score. So I'm just giving y underscore test because already model is trained and we need to predict the score on the testing set, and here we have to pass the probabilities similar to for k nearest neighbor. I need to pass this testing data set and probabilities for this one, right? And I'm just printing the logistic and nearest neighbor score. So here you can see I'm getting the 96% for the logistic regression and 87% for the nearest neighbor. So it's a clearly self-explained that the logistic regression ROC AUC curve based on these probabilities between the true positive rate and the false positive rate is performing excellent, right? Now let me show you how's the graph looks like. So for showing the graph, here I'm hoping like you are already aware with the basic concept how we can plot this graph and all. So I'm just giving the false positive rate for the logistic, true positive rate, and the line style, that is hyphen hyphen color equals to red, and the label which is going to print downside the curve, and it will denote the line and which line denotes to which curve, right? And after that I'm setting the title, that is ROC AUC curve, the X label for the false positive rate and the Y label for the true positive rate. If I compile here, you can clearly see the x-axis says the false positive rate and y-axis says the true positive rate, and here the label are there in the graph, logistic regression for the red line and KNN for the green line. So this KNN is for the this green line says for the KNN, and if you can see it's only covering a very limited portion, but if you will look at the red dotted line, and that is for the logistic regression, so it is covering the top till top, right, in the graph. At the downside area, that is AUC under the curve, area under the curve. So but if higher the area under the curve, better the performance, guys. So here we can see this logistic regression is performing very very well. So thank you so much guys here. So before ending this video tutorial, I would like to tell you that I'm just going to add this Jupyter notebook URL in the video link description after uploading to the my GitHub repo, and I'm just going to add the video description for my previous video tutorial, that is covering the confusion matrix, where already I have explained the true positive, false positive, true negative, and false negative, right? All these concept about is precision, recall, sensitivity, and specificity. So thank you so much for watching.